Now we're going to do some more interesting work. When you were in 6th grade, you were able to find the distance between 2 points on a graph, and usually the points they always made a line that was horizontal and vertical. Now we know how to find distance for diagonal lines on a graph, and you're going to find another way even later on in 8th grade in Algebra 1. So let's jump into this one. What is the distance between those 2 points in the line? -4, 2, and 2, 5. We're going to find that distance and round it to the nearest tenth. So our first question is pretty easy. What is the length of the diagonal line? Okay, we know what the 2 points are. They're the endpoints in this problem. And here's going to be my plan. We have 2 points there. I'm going to create a right triangle using a horizontal and vertical line. So I'm going to create a third point that is going to be a right triangle. And that's going to be super helpful because then I can use my theorem and I can actually substitute the A and B, because again, this is a skill we learned in 6th grade. We know how to find the distance of that line. But I can use those distances to figure out what C is. So hit pause so we can go and model this problem out. We want to make a right triangle out of these points. So I need a third point, meaning I'm going to find a point where this horizontal and vertical line comes together. So here's my third point. And that's important. It has to be a vertical and a horizontal line so that I have a right triangle. And this point is at 2, 2. So I'm just going to put my other points in there just so we have them. Here's 2, 5. And here is -4, 2. Let's find the distances over here. I know that this is A. I'm going to use the shorter legs. Here's A, here's B, here's C. This distance from here to here, it's a vertical line, so I'm going to use my Y values. So going from 2 to 5, that makes this 3. That's the distance for B. And going from -4 to +2, you can't just say 4 to 2. I like to use my point here to help us. So from -4 to 0 has a distance of 4. And from 0 to 2 has another distance of 2. So 4 plus 2, this entire distance is equal to 6. And I can't just count across this way because these are diagonal lines. So I can't just count them in the same way. We're going to have to use our Pythagorean Theorem. So let's start by using our formula. And we have a value for A, 6 squared, and B, 3 squared, is equal to C squared. Let's evaluate. 36 plus 9 equals C squared. 36 plus 9 is 45, is equal to C squared. Now we want the C by itself, so we'll find the square root of 45. Square root of 45 is equal to, let's see, 6.708 is equal to C, and we're rounding to the nearest tenth if necessary, so 6 7/10 is equal to C. The distance between both points is 6 7/10 units. Hit pause so you can jot this down into your notes. And this is just a really helpful strategy to use math marbles when we want to find the distance between any 2 points on a coordinate plane. If it's a vertical or horizontal line, we can just count. However, if it's diagonal, we can make a triangle by creating a third point and then using the Pythagorean theorem. All right, one more problem. This one's not a graph, but it is graphic. We can make a visual for it. Margaret leaves school to go home. Her bus drives 4 kilometers north and then goes 2 kilometers east. How far is her school if there was a straight bike lane connecting her house to the school. So yeah, you can see if this was just a word problem, it might get a little confusing. And we're going to round our answer to nearest kilometer. So I like that we have a visual there where it almost looks like part of a graph, and the origin, the 0, 0, is at school. So we want to know what is the distance between school and her house. And that's if we went straightly. The shortest distance between any two places is a straight line. Like if we made a straight line from school to her house, how long would that line be? We know that the line is going to be diagonal, and we know that the legs of the triangle. So again, I'm making a right triangle here will be 4 and 2. So if you're not sure what that means, I'm going to show it to you visually in just a second. I'm going to create that visual for the situation, and then I'm going to apply our theorem, substituting our values and then solving for C. So hit pause so you can jot this down, and I definitely want you to pay attention and watch how I'm making the triangle here. And once we have a triangle, it's pretty easy going from there. We know exactly what we're going to do. It's going to feel like muscle memory. So hit pause, jot this down into your notes, and we'll get to putting our plan in action. Okay, we're going to start off with a visualization, and just from the problem, again, we know that it is 4 north and 2 east. So let's plot that point, adding in those numbers, and now we can see the right triangle here. And we are using the Pythagorean Theorem. So let's substitute our values and evaluate. So 20 is equal to c squared. Let's find the square root of 20 using our calculator. And I'm getting 4.472 is equal to c, and we're going to round this to the nearest kilometers. So c is equal to 4 kilometers, and I'll answer that in context. Margaret lives about 4 kilometers from the school. And there you go. And again, this is just showing how in real life we can use triangles and angles to find distances. This is such a useful tool in real life, and is how we can map things out. You can put it into a real world context, all using this fantastic theorem. So we're going to hit pause here so you can jot this down into your notes, and you can get more practice. And again, just putting a tip, visuals really help. So you can see numbers, you can see where the angles actually lie, and that will help you as you're evaluating to get the appropriate answer. All right, Math Marvels, that is all for today. Take care, and I will see you in the next lesson.